Okay, now Tanushree, please start the prayer.
Om Shahana Bhavatu Shahano Bhunaktu Shahabiryam Karavavai Tejasvi Nabhadhitamastu Ma Vidabhishabhai. Om Shanti Shanti Shanti.
Thank you, Tanushree. Now I'm requesting Sridevi, please you update about the last 3 days.
Yes, sir. Good morning to everybody. We started on 24th of this month, and day one, it started with, class started with the introduction of the case study, wherein Dr. Rupali Joshi, she talked to us about SPSS. She talked to us about the nomenclature of SPSS and a brief background of its origin. Then sir showed us a data set pertaining to a particular project, wherein we learned how to transfer data from Excel to SPSS. Excel having .xls format, and the SPSS file extension was .csv. Why .csv? Because SPSS could only recognize a file which has .csv extension. Now, sir said that what is CSV? CSV is a comma separated value where delimiters are used. What is a delimitator? Delimitator may be a comma, a semicolon, a gap, or a tab. So that was the first topic, and then we moved on to how to remove the outlier. Sir told us what an outlier is, the concept about outlier, why is it necessary to remove the outlier, and then how we can remove the outlier. Suppose sir showed us that we had 331 data in the original case study, and then we reduced it to 216. So how we could do that, we learned in that part. And then this could also be represented to detect the outlier by using a graphical representation. The graphical representation being the box whisker plot, where we could identify the outliers, the outliers being the distant data which are higher than the maximum or lower than the minimum. So we could identify that. And then again, we could move on to descriptive statistics, where after removing the outlier, we could carry out our statistical analysis. After that, we went on to data visualization, where we could use 3 approach. Sir told us that we could use 3 approach for the data visualization technique. One is using the chart builder. We would go to graph tab, then we would move on to chart builder, and from chart builder we could proceed. The second approach was we can go directly to box plot, and the third approach is we can go to, from graph we can go to legacy dialog and then to box plot. So these are the 3 approaches we could adopt for having data visualization. And also in the box plot, how to draw simple box plot, we have learned from that. And all these things are related to data quality management. So it is very essential that we ascertain the quality of the data before proceeding to statistical analysis. Then we came to understand about skewed data. in skewed data, sir said that we could have a graph. I mean, we could identify whether our data is skewed or not from from by following the steps. Like we would go to analyze, then we would go to frequency, and then we will come to frequency chart. And by using the normal curve on histogram, we could find out whether our data is skewed or not. Skewed may be positively skewed or negatively skewed. So in positive skewness and negative skewness, we can ascertain whether the data are on the positive side, more data are on the positive side, or more data on the negative side. And correspondingly, we could also understand this sort of skewness from the box plot. So this is what we covered in the first day. And then in the second day, that is day 2, on 25th of May, we covered definition of charts using data summarization for categorical data. For categorical data, we learned about charts, and also how do we create chart using SPSS. So here we learned about the definition of bar chart, and also the types of bar chart, the kinds of bar chart. Bar chart is generally is of two types rather. One is the horizontal bar chart, another one is the vertical bar chart. We were shown the charts on the screen, and also the vertical bar chart. The other name of vertical bar chart is also the column chart. We came to know that, and how we could use SPSS in drawing the horizontal and vertical bar chart. We learned from that, and also how to interpret data. Main thing is from the importance of data visualization is to interpret data. So how do we interpret data from these two kinds of bar chart? We learned that also. So we were told that data visualization is a very, very powerful technique for policy research. So how do we do that? We came to understand. And also with respect to the nature of bar chart, we were told that they were double bar chart or bar graph. We may call bar chart a bar graph also, or a bar graph a bar chart also, in either way. And also the stacked bar chart or bar graph. Now, double bar graph is generally used when we want to compare one categorical data with a grand data or a grand total data. And stacked bar graph we generally use when there are two categorical data like boy, girls, male, females, etc. So this is the difference between double bar graph and stacked bar graph. Now in day 3, this is the continuation of the previous class, where we learnt about stacked bar graph. Stacked bar graph, here the main advantage of the stacked bar graph is that we can make comparisons between the categories of data, and also we can break down, we can break down a single bar or single band, so to speak, into several units, and we can compare the unit with the whole. That is a unit band, a band broken up into several units, and the broken unit can be compared with the whole band. And also we learned a very interesting thing, that is about the Likert scale. Now, Likert scale, it is a rating scale. Likert scale is a rating scale where we may have a 3-point Likert scale, or 5-point Likert scale, or 7-point Likert scale. Now, we learned that each of these option in the Likert scale, they have equal probability. They have equal probability, and also from this we can ascertain which one is the most probable option, and after that we can perform the chi-square test to say whether our observation is significant or not. So this is the interesting part we learned. And also we learned different, there are ways to visualize the Likert scale. So we learned that. Now, after that, we were given a definition about the stacked bar chart. Uh, And sir, lastly, we learned that that stacked bar chart are used in evaluation to show full scale of survey responses. That is from strongly disagree option to strongly agree option for each survey item. That is, if we have a questionnaire of 10 questions, then if we give options for each question, options like disagree to strongly agree, then we could ascertain then we could evaluate each option, and we can find out the significance of each of them. So, sir, this is what we learned. And one last thing we should remember, that the stacked value should always add up to 100%. It should be always, that is, percentage should always be 100. Otherwise, the interpretation or whatever data we are getting, that won't be correct. So, this is what we learned, sir. If I've missed anything.
This is nice. You have covered very nicely. So today we will learn about the difference between means. Okay. And basically it is the hypothesis testing. Can anyone tell me what is called hypothesis? What is called hypothesis? Hypothesis is the pre-assumed assumption. When you have specific type of assumption based upon your observation or the literature review, you can go for the hypothesis testing. So when we are testing the hypothesis, we are trying to explore, or we are trying to determine the extent of difference between the observed score and the expected score. Okay. In case of the chi-square test, we are assuming equal probability hypothesis. Accordingly, we are examining to what extent observed frequency is deviated from the expected frequency. So that is in case of the chi-square, when your data are categorical in nature. But when your data are numeric in nature, when your data has score distribution, then you can think about the difference between your distribution mean minus population mean. So what is the population mean? Population mean is the 0. Okay. Population mean is the 0. So we have to find out to what extent your mean is deviated from the population mean. Why it is 0? Because mean, median, and the mode, they are all at the same point, and the distribution is based upon the normal probability curve. Is it clear, or any question? So normal probability curve, you can write down normal probability curve. Please you write. The normal probability curve is symmetrical about the ordinate of the central point of the curve. It implies that the size, shape, and slope of the curve on one side of the curve is identical to that of the other. Okay? Normal probability curve. Now I am presenting you the normal probability curve so that you can easily understand. I'm sharing the screen. So there are many normal probability curve you can find out, but it is better to think this particular curve. Okay, the definition of normal probability curve, it is very clearly written. And you will find that is the mean, median, and mode. Okay. All of them lie at the center point. So this is 0. So there is no difference at all. And the normal probability curve it is written, it is symmetrical. Okay. So 50% of the total population above the mean and 50% of the total population below the mean, the distribution is same. So it implies that the size, shape, and slope of the curve on one side of the curve is identical to that of the other. I think this is clear to all of you. So the normal probability curve has a bilateral symmetry. So now you follow this curve. Okay, you will find the bilateral symmetry. So you can find out the z-score 0. Z-score means standard score. So when we have the raw score, we are converting this raw score into the z-score so that we can find out to what extent the raw score is deviated from the standard score. Standard means normal probability distribution. But why do we use the normal probability? We are using normal probability for inference purpose. If you are interested to make any inference based upon your sample data, okay, that means you are making generalization for the population. Up to this, is it clear to all of you? Okay. Now you can find out three sigma rule. What is this 3 sigma? Here you will find the 34.1 and 34.1, so 68.2. হ্যাঁ বলো বলো অনুশ্রী অনুপম হ্যাঁ ও তবে তো এটা যেটা আছে সেটাই আমি তবে ক্লিয়ার করে দিচ্ছি ওকে ঠিক আছে থ্যাংক ইউ okay so please you write down the empirical rule in statistics allows researchers to determine the proportion of values that fall within certain distances from the mean. Full stop. The empirical rule is often referred to as the 3 sigma rule or the 68, 95 and 97. Now please look at this picture. So this is the 68, okay, and the next one is the 95%. After that 99.7, that is the 99% rule. So this is the 3 sigma rule. So when you say that is your score is applicable only for the 68%, that means you have more number of errors for population inference. And when you say 95% cases, similar score you will get. Okay, then you can think that is 5% error is there. For example, you have assessed the effect of online training on student performance. And you have tested it. And you have noted that is the findings is significant for the 95% of the people. Okay. This can be allowed because 5% error, that is very much expected in social science research. But in case of the medicine, suppose you want to examine effect of antidepressive drug on depression. Then if you find it is 95% cases, it is okay. So this is not sufficient. 5% error means in 5% cases, the antidepressive drug may not have good effect. So this is not reliable drug. What usually happens in case of the corona vaccine? So what is important? Repeated observation. Repeated observation, that is important, and the data should be large. When your data is small, for example, you have applied the vaccine on 5 people and you have received good result. So that does not mean you can apply this vaccine for the total population of India. Okay. Therefore, what is important? Large number of data. And the second one, repeated observation. Repeated observation. When your observation will be the large, that means when you will collect the large number of data, then you will find that is error is reduced. Okay. So when your error is reduced, so this error means standard error. Okay, standard error of mean, that will be reduced when your sample size is large. Is it clear to all of you? Or any question? So this is the picture. Please look at this picture. The formula is written here: standard error of mean equal to standard deviation divided by root of your sample size. And you will find that is the x-axis, that is the sample size, and y-axis is standard error of mean. So when your sample size less than 20, okay, then your standard error is high. But when your sample size is more than 80, then your standard error of mean is small. Okay, so what will be our target? That is the standard error of the mean that should be small. That means sampling error is small. Okay. To make small sampling error, we need to use as large of a sample size as we can manage. This is clear to all of you, or any question? Okay. Now we will learn about the confidence interval. So how much confidence we can give, we can assign to the score. How much confidence we can assign to the score. For that reason, because when we are talking about the confidence interval for mean, for example, this is the picture. Please you follow this picture. Okay. So when it is 1.96, then you can think about that 1.96 your jet score. You can think about the 95% confidence. And when it is 2.58, then you can think about the 99% confidence. So what is this? It means you have collected data and you have some sample distribution. You have the mean. You have the sample mean. And you have to find out to what extent your sample mean is deviated from the population mean. So to find out this, you have done the standard error of mean. After that, you have to multiply it with the Z value. Okay. Suppose your standard error of mean is 4.2. So you have to multiply 4.2 into the Z value 1.96. And then you have the score, and from the score you have to find out the plus minus deviation of the multiplication of Z value and the standard error of mean. And then you can get some idea about the confidence interval. So you please write down confidence interval. Confidence interval is a range of estimates for an unknown parameter. For an unknown parameter. Full stop. A confidence interval is computed at a designated confidence level the 95% confidence level is most common. But other levels such as 99% or 90% are sometimes used. Confidence interval is a range of values that is likely to include a population value with a certain degree of confidence. It is often expressed as a percentage whereby a population mean lies between an upper and the lower interval. Between the upper and lower interval. Okay. So here you can find out the between the upper and the lower interval. That is another picture, you can see it. So you can find out the lower confidence interval. Another one is the upper confidence limit. For example, the probability of the population mean value being between minus 1.96. So in this picture, you will find the minus 1.96 and plus 1.96 standard deviations or standard scores or Z scores from the sample mean is 95%. Full stop. Accordingly, there is a 5% chance that the population mean lies outside of the upper and lower confidence interval. Is it clear to all of you? So this confidence interval is very important when you want to infer your score for the population. Is it clear to all of you or any question? Now I am coming to the one sample t-test. What is one sample? One sample does not mean single case. Please you write down. One sample t-test is a statistical hypothesis test used to determine whether an unknown population mean is different from a specific value.
Sir, can you please repeat it?
One sample t-test is a statistical hypothesis test used to determine whether an unknown population mean is always unknown. Now look at this picture. is different from a specific value. This is the one sample t-test model. So now you go to the formula. It is written the mean, that is the sample mean, minus population mean, divided by sample standard deviation divided by the square root of sample size. So this is the formula. By using this formula, you can calculate the one sample t-test. Is it clear to all of you? Hello?
Yes, sir.
So here I am writing some arbitrary data. Is it visible? No.
No, sir.
I am writing some arbitrary data, but before that, I am writing the variable. Variable name is test. Okay. So it is measured scale. Okay. Now I am going to the data view. Test is there. Maybe this is your Bengali test. Okay. So one individual received 45, another individual received 50, 40, 35, 30, 25, 30, 25, 23, 24, 20. Okay. So I collected data from the 10 individuals and I am going to the analyze. And there is a compare means. Okay. Now again, this is another variable. It is the arbitrary data. I am writing sex. Okay, sex. That is the nominal data. And I am making it value. So if value is 1, that means female. Add it. Okay. Now again I click it, value is 2. Then it will be the male. I add it and okay. Clear? Now I am going to analyze. There is compare means. if I write down the means, so means means dependent variable. That is my dependent variable. And shakes is my independent variable. If I click it OK, oh, sorry, I have not given any data. Yeah, I have to give some data. Okay, is it visible? Hello.
Yes, sir.
Now I am clicking analyze, compare means, only the means. I do not want this one, only the means. Then I can click it one. So I will get the, that is 10 individuals are there. What is the report? Report lies that standard mean is 32.20. Okay, and the standard deviation is 10.06. Is it clear? So I am getting only the mean, but this
Sir,
is what.
window ta asche na sir.
Oh, thank you. Now it is visible.
Ah, sir.
So if I go to analyze, then compare means, and if you click the means only, then you will get this result. So you will get only the means, nothing more than that. And if you want to get something more, you can, many things are there, you can add all of them. So minimum, maximum, variance, kurtosis, many things are there, skewness, all those things are there. So you can test it. So I am writing okay. This is visible now. Hello.
Ah, sir. Ah, sir.
তা দেখতে পাচ্ছ এখানে now you can find out that is the mean 32.20, sample size 10, and that standard deviation is 10.06. Minimum is 20, maximum 50, variance 101, kurtosis minus 0.775, skewness 0.639. So when it is very close to the 0, that means the distribution is okay. Now I am coming to the again analyze, and again the compare means, and I am writing, sorry, analyze compare means, again the means. You will find the dependent list, another one is the independent list or layer 1 of 1. So I am writing here 6, then okay. So now I get this data. It is visible to all of you. So female data and the male data.
Yes, sir.
Male is 31.6 and female is 32.80. Is it visible? Hello. দেখা যাচ্ছে?
Yes, sir.
हाँ sir.
না দেখা গেলে বলবে। আচ্ছা। Now if I go to the analyze again, compare means and one sample t-test, then I can take only one variable. So what I find, that is the p-value 10.11 df9, and it is significant. Okay, and you will find the 95 confidence interval of the difference is 25 and 39, and you will find that is the mean difference that falls between the lower and the upper confidence interval. Is it clear to all of you? Hello?
Sir,
Yes,
sir,
এটুকুই থাক, হ্যাঁ।
sir, mean difference, sir, এই ডিফারেন্সটা মানে কার মধ্যে, মানে ডিফারেন্স বিটুইন কোনটা স্যার?
Difference between your sample distribution and the population mean.
আচ্ছা আচ্ছা স্যার, পপুলেশন মিন তো এখানে কি ওইটা?
Zero. Population mean always 0.
আচ্ছা, পপুলেশন মিন আর স্যাম্পল মিনের মধ্যে ডিফারেন্স হচ্ছে এইটা 32.2।
হ্যাঁ, হ্যাঁ।
ও আচ্ছা আচ্ছা, ঠিক আছে, বুঝেছি।
Okay.
হুম।
Okay, I think it is clear to all of you, because today I have shown some of the pictures also in association with the class note. If you have any question, you can ask me. Otherwise, I'll close it. Okay, so no question. So please, you go to the Google Classroom for the question. I will give you the question. And your performance indicates that is whether you will get certificate or not. Okay, Tanushree, please. Prayerta karo.
Om Purnamadah Purnamidam Purnat Purnamudachyate Purnashya Purnamadaya Purnamevavashishyate. Om Shanti Shanti Shanti.
Thank you, Tanushree. So now our 4th day class is over, and tomorrow is the 5th day class. Okay.